we already know that the cosmos is one of a kind. We're wondering if we're the only ones here. Perhaps there is life outside of us that we are unaware of. Scientists have seen some flashes from space in a galaxy 12 million light-years away. For the scientist, these flashes feel familiar, almost like a déjà vu. But what are these flashes? Is this a signal from another life? And how can this affect us? Keep on watching to find out more. So what are these flashes? The lights, which are known as a repeating fast radio burst, FRB, resemble those seen in the Crab Nebula. The repeating fast radio burst has the name FRB 202000120E. But what exactly is repeating fast radio burst? A fast radio burst, FRB, is a transient radio pulse with a duration ranging from a fraction of a millisecond to a few milliseconds in radio astronomy, created by an unknown high-energy astronomical activity. According to astronomers, the typical FRB emits as much energy in a millisecond as the Sun does in 3 days. The power of the signal reaching Earth has been described as 1,000 times less than that of a mobile phone on the Moon, despite the fact that the signals are incredibly intense at their source. So, these flashes, also known as these repeating fast radio bursts, have been seen in the Crab Nebula. But what is the Crab Nebula? In 1054, Chinese astronomers saw a guest star that was visible in the daylight sky for about a month. The guest star they saw was really a supernova explosion, and the Crab Nebula, a 6 light-year wide relic of the catastrophic event, was formed as a result. The Crab Nebula may be seen with a modest telescope and is best visible in January, with an apparent magnitude of 8.4 and a distance of 6,500 light-years from Earth in the constellation Taurus. Because the remnant could only be seen via a telescope, the leftover nebula was discovered for the first time in 1731 by British astronomer John Bevis. After seeing it for the first time 27 years later, French astronomer Charles Messier added it to his now famous catalogue of Messier objects, naming it Messier 1 or M1. In 1731, English astronomer John Bevis discovered the nebula, which was subsequently viewed by Charles Messier, who mistaken it for Halley's Comet. Messier was inspired by the nebula to compile a list of celestial objects that may be mistaken for comets. Hubble collected 24 separate images of the Crab Nebula over the course of 3 months, resulting in this huge mosaic. The colors in this image don't quite match what we perceive with our eyes, but they do reveal information about the makeup of this magnificent stellar corpse. The orange filaments are mainly hydrogen and constitute the ragged remains of the star. The blue filaments in the nebula's furthest reaches depict neutral oxygen. Singly ionized sulfur is green, and doubly ionized oxygen is red. During the supernova explosion, these elements were released. This all happened in galaxy M81. M81 is one of the night sky's brightest galaxies and it's 11.6 million light-years away from Earth, making it the closest known extragalactic rapid radio burst, 40 times closer than the next closest extragalactic signal. Some of the signals we measured are short and extremely powerful, in just the same way as some signals from the Crab pulsar. Said by Kenzie Nimmo, it wasn't until the 1960s that scientists identified a flickering radio source near the Crab Nebula and discovered that the signal was coming from a pulsar. So, the signal came from a pulsar, but what is a pulsar? Pulsars appear as flashing stars from Earth. They appear to blink in a steady pattern, on and off, on and off. Pulsar light, on the other hand, does not flicker or pulse, and these objects are not stars. Pulsars produce 2 narrow, constant beams of light that travel in opposing directions. Despite the fact that the light from the beam is constant, pulsars appear to flicker because they rotate as well. It's the same reason why a lighthouse on the water looks to blink when viewed by a sailor. The beam of light from the pulsar may swing across the Earth, then swing out of view, then swing back around as the pulsar spins. The light comes in and out of vision for an astronomer on the ground, creating the impression that the pulsar is flashing on and off. The light beam of a pulsar spins around like a lighthouse beam because the pulsar's axis of rotation is usually not aligned with the pulsar's axis of rotation. Despite the fact that the Crab Nebula's bursts have a recognized source and are identical to those seen in M81, astronomers aren't sure what's going on in galaxy M81. These FRBs were first seen in January 2020, originating from the direction of Ursa Major, the Great Bear constellation. FRBs have typically been discovered in galaxies with young stars, but the M81 observations are unique in that the source of the signal was located to an ancient clump of stars known as a globular cluster using a network of a dozen radio dishes. But what is a globular cluster? Globular clusters are clumps of old stars that are firmly packed together. They have a roughly spherical form and contain hundreds of thousands, if not millions, of stars. Astronomers can use them to determine the age of the cosmos or the location of a galaxy's core by studying them. There are around 150 identified globular clusters in the Milky Way galaxy. The majority are thought to be at least 10 billion years old, and include some of the galaxy's oldest stars. Before the galaxy flattened into a spiral disk, the clusters most likely formed. One theory about FRBs is that they are caused by magnetars, which are the universe's strongest magnets and another sort of supernova remnant. All stars, deep into their cores, burn hydrogen into helium. The energy emitted protects the stars from their own gravity's crushing weight and, as a bonus, provides the warmth and light required for life on any surrounding planets. However, the core's fuel ultimately runs out, enabling gravity to briefly triumph and squeeze the star's core even more tightly. And while this theory makes sense in situations where young stars are prevalent, it's more difficult in M81, according to the researchers. In a statement, Jason Hessels of the University of Amsterdam and Astron said, "We expect magnetars to be shiny and new, and definitely not surrounded by old stars. If what we're looking at here really is a magnetar, then it can't have been formed from a young star exploding. There has to be another way. A white dwarf might be one plausible reason. The added mass may have led the white dwarf to collapse into a magnetar over time, according to the researchers. White dwarfs are the last visible stage of development for low and medium mass stars. They are dense, faint stellar corpses. According to NASA, a low or medium mass star with a mass less than around 8 times that of the Sun will eventually become a white dwarf, whereas most large stars will eventually go supernova. Approximately 97% of the Milky Way's stars will ultimately turn into white dwarfs. So, there are a variety of places where these FRBs might originate. It's possible that certain scenarios will be mixed up. Every now and again, a globular cluster is discovered to be home to a millisecond pulsar, a kind of fast revolving neutron star. Because globular clusters are so closely packed, stars can interact and even collide, resulting in things like low-mass X-ray binaries and pulsars. According to the researchers, this opens up new possibilities for magnetar creation beyond a large star's core collapse explosion. A low-mass white dwarf might gather enough mass via interacting with and accreting material from another star to collapse into a neutron star, or 2 white dwarfs could unite to achieve the same result. It's also imaginable that the FRB's source is a low-mass X-ray binary, such as a white dwarf and a neutron star, or a neutron star and an exoplanet, rather than a magnetar. It's also possible that it's an eroding black hole. Although the evidence for these theories is sparse, no X-ray or gamma-ray activity is normally associated with these systems, they cannot be ruled out. Whatever the solution, it appears that the FRBs are about to change things up. Either it will tell us something new about globular cluster star interactions, or it will provide us with a new FRB formation pathway. Because it's a repeat FRB so close to us, it's a once-in-a-lifetime chance to investigate these mysterious signals in depth. For the time being, these FRBs pose no danger to us, and there is nothing to be concerned about. The only question that researchers have is where the FRBs came from exactly. So what do you think about these flashes from space? And where do you think they came from? Let us know in the comments.